Hi, everyone. This is Jay from InterviewQuery.com, and you're listening to the Data Stream podcast. It's a show where I talk to data scientists that work on interesting projects with practical applications to the real world. Today, I'm talking to Tyler, who did his work on a lot of election integrity stuff, as well as previously worked at companies, nonprofit called Protect Democracy. Currently, he is a data scientist at Facebook. Tyler, welcome to the podcast.
Thanks for having me.
Yeah, crazy times, but I'm glad that we can get on the Zoom call. But I think all the previous podcasts were all over Zoom anyway, so it's like, or like some form of remote communication. I don't think I've had an in-person one yet. And I've always wondered about that too, just to see if it would actually make like the dynamic a little bit different too. I've heard like if you open like a few beers and then you start talking, then it gets like a little bit easier, but I'm not sure.
Yeah.
Well,
you should do an A/B test. You should start two podcasts, one that is in person and one is exclusively over Zoom.
Yeah, exactly. And the one that's like in person, I'm sure it just derails with like half the episodes don't actually start recording, and then
yeah,
fails that way after like a few years. But that is a great idea. I think I've been trying to A/B test some more things in my life as of recently. I think the COVID-19 pandemic is like a good example of how it's not like A/B testing anymore. It's just more like your life is now one thing and now it's another, which in a lot of data science is like the what you call the like no A/B testing. Let's just release the feature kind of testing where you try to see if something has changed. So far, I think the effects have been less exercise and more news.
Less exercise. More news. Yeah. I mean, that's one thing so as you said before, I work at Facebook now. It's been interesting because so many more people are just on the internet the whole day now.
Yeah.
And so all of engagement for every sort of social platform, I'm sure, is like absolutely through the roof. Like I'm sure Pinterest is just going crazy right now.
Yeah, definitely. I think Pinterest, the company that I used to work at next door as well, I think they're seeing huge engagement in terms of like people, neighbors trying to help each other out, hopefully, and talking about obviously coronavirus. And I think also just like a lot of the interesting stuff with COVID in terms of generally like the news that travels through like the different social networks has definitely kind of changed how you guys view the different metrics of engagement too, I'm guessing, right?
Oh yeah, for sure. It's been very like fascinating at Facebook because I've been there for about 9 months now, and I've been shocked that a company of like such a great size is able to pivot on so many things so quickly. Like you would expect that a group that has tens of thousands of people working for them like could not pivot quickly at all. The company that I interned for 2 summers, Procter and Gamble, is like super old and remarkably innovative for being like 200 years old. But still, like I could never imagine them at 100,000 employees pivoting towards any sort of business model change over the course of even like 5 years or something, much less a few months, where it's like a lot of the questions internally at Facebook are, okay, advertising gets hit like really hard during coronavirus pandemics, during every time the economy is going down, advertising is obviously going to be one of the first things that gets eliminated from budgets. So like where else can we support like small businesses other than just giving them more ads? And so we started out giving them more ads, and now there's all these other kind of things that are popping up, and it's been really, really fascinating to see, for sure. And engagement is just through the roof in everything you can imagine.
Yeah, and I can definitely see that happening with Facebook more so because it seems like they have a grasp on changing things pretty quickly after events happen. Like I think 2016 was a good example of that with the elections, and like understanding that I think an entire like integrity team was like built just to support a lot of the fallout effects from a company being that big in terms of like size and in terms of like influence, right, on the
Yeah.
entire world. And I think having that is interesting. And it also kind of ties back into some of the stuff that we were talking about before with your past experience, right? Because working at a place like Protect Democracy, which is definitely like an intense, I think, also just nonprofit name in itself. Like we are protecting the heralds of U.S. democracy, but it's like it's from what I understood from going on the website was that it does a lot of about checking like systems and balances in place and making sure that the system that the democratic system the U.S. is good with like a couple of like core values in terms of like elections, protecting communities, and I guess in terms of like I'd love for you to just like go a little bit more into that and like if you think if it relates kind of to your work at Facebook now at all.
Yeah, for sure. Yeah, Protect Democracy is really interesting. It's like a really fun / intense group of people to work with. So it was founded by some people that used to work in the Obama administration. And then once they left the Obama administration, they decided that it was basically a group of like really smart lawyers that wanted to really, they named it pretty aptly, like they wanted to protect democracy in any way that they could. And so I actually wasn't incredibly involved with the kind of lawyer side of it. They were mostly involved with like litigation efforts, and they do a lot of really cool, interesting work. They also have a subsidiary of them that is called Vote Shield, which is just a technical team. Like it is basically like a few developers, a bunch of data scientists, a bunch of data engineers, a couple PMs that was just working on the election infrastructure of state voter databases, which is a really niche and interesting kind of subfield. And really kind of what it is you don't really think about it until like someone mentions it to you, but every state has to have some sort of a giant list that has where all the people that are registered to vote live, if they've moved, how often they've voted, because they have to answer, states have to answer questions like, where should I put my polling location? They have to answer like, how many polling locations should I have? Like, are a bunch of people that are high propensity voters moving to this area? Who should I actually allow to vote? Like someone's gonna walk up to this polling place and it's gonna say, hey, can I vote? And you have to be able to know, oh, this is actually the person that they say they are. So they basically have to keep this giant voter database of all of their voters. And as you would kind of expect with a multi-million row database that is run by the state of Maryland, it's not a great database. And it's not an incredible database, and they don't do things that like a traditional tech company would do, like keep change logs and like have really good just data engineering like working behind it. And that's nothing bad about these states. It's just a state is not going to be, it's not going to be full of a bunch of data engineers. I really hope that like whoever is recruiting data engineers at each individual state is able to find like top tier data engineers, but it's really hard to do.
Yeah.
Yeah. And so one of the hard things is each state has their own unique database with its own unique information, kept in its own unique way. And that goes far back into history as long as they kind of want to. So they could have voter history that is, you know, for the past 30 years, they could only keep the past 5 years. They could keep like first, middle, last name in just one column or just in 3 columns. It's exactly what you would expect when you would say, let's have 50 different solutions for the same problem.
Yeah.
And so there's no unified way of knowing like who is registered to vote in this country. There's no unified database. And a couple of the problems that the Vote Shield group was trying to solve is creating this unified mechanism for a state voter or for a national voter registration database. Because there are consulting firms that have kind of sat on top of all these databases, done all the work, and then sold it to campaigns, sold access to that for campaigns, because obviously campaigns have to do it. But the thing is, that's incredibly expensive. And so if you're a researcher at a state institution, like I went to the University of Florida, and we have a bunch of great professors that work with state voter files a lot. But if if I'm a research group, I can't afford it literally costs like $250,000 for all of this data around the country, because the dirty secret of like voter data run by states is that the states literally sell your data. Like you can go to a state and you can say, here's $500. Can I have this voter registration database? And they will send you a CSV file. Like that's how it works. Like it's the most clear like selling of data that I've ever seen. And so if you're anyway, what I was saying is the thing that VoteShield does is it collects all of this data, and then it combines it all together into a unified format, which is a remarkable data engineering challenge. Does change files, so it looks at the change of those files over time, and then the design of it is kind of twofold. The first is actually, it's super interesting. It's trying to detect if there is some sort of foreign intrusion into this database. So if the kind of the easiest way to swing an election is basically to take 60,000 voters in a few states, drop them off the voter rolls, and then you can swing a national election. So that when they actually show up to vote, the people that are running the polling site are like, oh, we don't have you here, you can't vote, like you're not registered. And all that would take is just to drop, call it 60,000, 100,000 people in a few databases around the country, and you could successfully swing an election one way or the other.
Yeah.
Yeah, it's pretty nuts. It's pretty nuts. And it's these like very important databases that are run by not the best like security engineers out there. No offense to the people that run these, they do a really great job, but it's just a hard job. And it has massive importance for national politics.
Yeah, I get.
And so, go ahead.
No, I mean, I definitely see like the implications of that are pretty insane. And the fact that, these voter like registration databases are like different within each state makes it like pretty complex in terms of the fact that it seems like these are like building up systems from just like the transition from like over time, right? Where back in like history, I'm sure that someone was a person that actually had to like build each system out individually, right, for each state, and these are all different people. Whereas if you see something like the word isn't really authoritarian approach, but just like a top-down model of like building out a system from the national level to each one, seems like that is what's being done in like different countries that maybe are more, I guess, centralized in terms of government versus like this kind of reverse engineering. So now it's like you're kind of taking like dead code and almost like not dead code, but just generally like rewriting technical debt almost, right? And so would you say that a lot of the work there was then dealing with the technical debt, even though it had like great importance in terms of like the national security and like company, or was it like more of it around also just like analyzing this data to understand if there was any like election interference happening as well?
Yeah, it was definitely, I would say, both. A lot of the work that I specifically did was on the data engineering side.
Yeah.
So it was creating a unified system, and then like once that is created, then you can do a lot of really interesting work on it. But probably maybe 60 to 70% of my work was on the data engineering side, and then the rest was on the like more data science side. The civics word that you're kind of looking for is federalism there, which is basically, just the idea of like, oh, should we have a bunch of states that kind of run their own thing and have their own tax systems and whatever else? Or should we have one central government that is like dictating how kind of everything is run? And there are some benefits to having like a very non-unified approach. Like if everyone is running their own security system, then if you get access to Maryland's election infrastructure, you only get access to Maryland's, you don't get access to anyone else's. And so if you're trying to swing a bunch of local elections, you have to run like independent hacks on each one, which I guess if I was trying to hack, it would be annoying, but because I'm not, it's great.
But the argument is also, right, because for their existing system, right, you could just have to hack like Ohio and then Florida, and then you probably swing an election that way, given how the existing electoral college system works.
That's exactly true. So that was the thing that we're trying to kind of combat is there are good reasons why states should remove people from these voter files. Let's say the state thinks that you've moved. Maybe you haven't voted in like 3 elections or something like that. Maybe usually what happens is if you haven't voted in a couple federal elections, the state will send you a letter. I know everyone reads their letters these days. And it'll just say, hey, you haven't voted in a while. Like, do you still want to be registered? And if you don't respond, they'll just kick you out. Which, some people have, like, a lot of my old professors have a very strong problem with that. They're like, just leave them on. Like, who cares? Or wait 3 federal elections or something.
Yeah.
But a lot of people care very much about it. And so the big like data science problem there is, let's say you have a section of the population and you know these demographic characteristics from the voter file. Maybe you know their race, maybe you know their gender, you know how often they voted, you know their age, you know when they registered, you know their address, you know all these things from the voter file. These voter files are actually remarkably specific in terms of personally identifiable information.
Yeah.
And so if you know this population that has left the voter file, that the state has had in one voter file and then doesn't exist in the next one, is that a anomalous situation or is that a regular situation? Is that something that we would expect, or is that something that would throw a lot of red flags? And so that's kind of the fundamentals behind what is the data science problem there. And so you can do a lot of like individual level kind of prediction questions where you can say, what is the chance that this person, given that they voted in the last election and have been here for like 6 years, move or leave the voter file or pass away or whatever else it is? Like, what is the chance that you can do that? You can also look at it at a population level. So what is the probability that the set of people is anomalous or is kind of normal? And so that's kind of the data science question that sits on top of these voter registration databases. And it becomes pretty obvious pretty quickly that you need a lot of data from like, history going back through multiple federal elections to start to get really good at answering this.
Yeah.
And the technique of vote shield, which, but
oh no, sorry, go on.
The technique of vote shield is not to say that any specific anomaly was like, oh, this had to be the Russians or something, but it was more of, oh, these are really anomalous. We should flag these to the people that run the databases. So we can do this months in advance. Like we can start to detect these things like when they actually get kicked off of the voter rolls instead of the time that you would normally see it, which is when the person actually goes up to vote.
Gotcha. And I guess there's 2 things that are kind of lingering for me there. Is that one, is there any like general political incentive for people to have this come out one way or the other? So let's say that you identified something as kind of anomalous, it's kind of weird, but at the same time it's like, is there any way in which like someone could actually manipulate that to be like, okay, that actually, theoretically they go like, okay, that works well for us, let's like not investigate it, that works great for our, like, now this is a blue state turned red or something, not state but county or something like that. And then the second thing is there any way for you guys to actually verify what is like maligned or actually like suspicious in terms of getting like that supervised kind of like data set, right? Because I'm assuming that a lot of these methods are first intrinsically like heuristics that or just general like properties that you see, but I mean, if they are unsupervised initially, then it's definitely tougher than being able to have like that concrete we know that this is like an attempt of election hacking of some sort.
Yeah, so a couple questions there. I think I'll start with the first one. it's kind of two-sided. Once you start to understand kind of who these groups are that are running these state voter databases, most of them are kind of what you would think as like technocratic civil servants in a way, where they're these groups of people that like care very much about state and local governments, and they have some level of like technical skill enough to set up these very large databases that are run by state institutions and actually like moderate those over time. And so most of these people actually have been in their jobs through many administrations. So they were in Florida while Florida was blue, and they were in Florida while Florida was red, and then they kept going when it flipped and flipped and flipped. And so for a lot of these people that are actually on the receiving end of these analyses are usually people that are aggressively nonpartisan, which is nice. So if you were to send it to like an administration, like if you were to send it to like, I don't know, Brian Kemp or something, the governor of Georgia, then I wouldn't be incredibly confident that that man would do what is best for Georgia. No offense to, actually offense to Brian Kemp. I'm not sure he's very good at his job. Yeah. But I wouldn't trust him with like, oh, you listen, like here's the p-value for the statistical test that we ran. Like Brian Kemp, like do something about this, you know? Like no way. But most of the people that are actually working with this data are like very, very nonpartisan. The other set of people that are kind of consumers of this sort of analysis are university researchers. So there is often like the political science department that is closest to the state capitol usually will have some sort of knowledge of how the state voter file works, and some people that are kind of checking in and doing their own kind of mini sets of these analyses. Maybe they'll look from time to time and they say, oh, like why did all these people leave the voter file? But they don't really do it in a very institutional way because frankly, it's really hard and expensive. And a lot of university professors, like it's a really difficult thing to do. And especially in political science departments, like the chance that you're gonna have a bunch of students at a given time that are gonna be able to run all the AWS servers that you need and like the data set diffs that you would need to do that. And like it's unlikely that many universities, many political science departments can do that. There are certainly a few, but not for all 50 states. And so they are also the consumers of this sort of data and this sort of work. And I wouldn't exactly say that university professors are nonpartisan, but they certainly like can't use their partisan intent to swing elections in the same way that I would be worried about for like, again, if Brian Kemp got the analysis of the data. So that kind of answers like the first bit. Could you remind me of your second question again?
Yeah, the second question was on the general like validity of a lot of these like these algorithms, right? Or the detections of like anomalies and stuff.
Yeah. So there's it's kind of multifaceted as well. So most of the machine learning that sits on top of these kind of has to be unsupervised by nature. Because the instances that have been happened with kind of voter like hacking like hasn't really ever been 100% proven that it's happened or hasn't happened. And I would guess that if it has happened in any sort of a state capacity, that states wouldn't exactly tell a lot of people about it. That would kind of be kept under wraps. So it's really hard to know like what sort of binary classification problem that you're working with to know if, oh, this was irregular and this was regular. And then even if we can get some signal into moving it toward a supervised rather than unsupervised machine learning problem, it's really hard to be confident in the labels that you actually get.
Yeah.
And then even if you got those labels, the number of labels that you would have that would be positive versus negative, like it would be so unbalanced in terms of the binary classification, because there's so much change that happens in these voter files that it would be really hard not to overfit. And we're not exactly sure that even if you built that model, if you could make it like halfway reasonably good, given all of those issues with it, that people would rather see, oh, this was definitely like weird or anomalous, or this was definitely election hacking, because election hacking looks very similar to a whole host of other things. And so the actions that come off it may not be that different. There was one section of the Mueller report that focused on this exact thing, which was interesting because I was working there at the time when the Mueller report came out. And they had basically found that there were a couple counties in Florida, and there was one, I think it was one other state that basically Russian hackers had actually gotten access to the database, to the like actual state voter registration database, which was like pretty interesting. But then again, it was only like over a period of time, and it was, if I remember correctly, I think it was read-only access, which I'm sure not a lot of people that were reading this report knew what that really meant, but it's all right. Yeah, so I think those are the general problems that kind of come out of it. Anyway, I think the group is like really great and really interesting, and I loved working with them a lot. They're fantastic.
Yeah, and it sounds like it has a lot of practical just work and meaning to it, I think, which is definitely important. And I think it also kind of like goes back to that feeling of kind of contribution in data science projects that you get when you're working within the data, and then you also get to write about it. And you've done your fair share of like kind of side data science projects that you can see on the website, with like looking at like the pizza in New York and then the Hillary slogan. I think it kind of just goes to show how like this kind of practical application work is super interesting, and it kind of gives you that edge in terms of like reporting as well. Because I've always felt that at least data science for me was like a really good opportunity to like have something to actually showcase that no one else does. And that's basically most of journalism too, with just some good writing, I think, is just like being able to investigate into these things. But now it's like you have superpowers into like looking into a data set when someone else just sees like, I don't know, there's like the matrix lines, like doesn't make any sense.
Yeah.
But yeah, I think,
I'm sure there's like, I have a theory that there's like a bunch of journalists that if you gave them a 4-week class on SQL, could be like really good data scientists in a really short amount of time.
Yeah, and I think that is actually what the New York Times is doing right now, actually, to boost their journalism efforts. Yeah, is to have like internal like data science like lessons and classes, just to help their like data education across the board, to get the baseline up from just even like knowing how Excel works and like being able to do some of those basic functions. Like you don't even have to get into the coding part, right? And then SQL is obviously like pretty well needed at that point. But
they have a really good, they have the Upshot, right? Like that's the New York Times, the Upshot. Like they have some of the best data journalists and data visualization people like out there, I think.
Yeah, they definitely do. I think just because the data visualization part as well, like having that extra like refined approach towards making your visualization better is like, I do think it generates a lot in terms of just the engagement that it can get. And not a lot of people think about that, especially when like, obviously the creator is like data scientists like you or me, and you're like, everyone can read this like histogram, obviously, and like understand what it means. When really that interactivity of like just hovering over and like having a label appear is like surprisingly effective in terms of general interpretation. I've definitely seen it so myself when I've like looked over other people's projects versus then going to like the New York Times and seeing how interactive their stuff is. And yeah, I definitely think there's a lot of work in there involved.
Yeah, I think I've always wanted to like take like a month and learn like D3 really well, because I feel like if that's a step that I've kind of always wanted to take, but have never taken out like a month of time to really learn it well, just because I don't have a ton of front end experience or JavaScript experience. And so many people, you know, I follow a lot of JavaScript developers and like front end people on Twitter, and it just seems like a whole different world. There's a lot of stuff going on there that seems super interesting and super difficult, and I'd love to learn it, but I haven't taken the time to do that yet. The other website that I think has my favorite visualizations of all time is, have you ever been on the Pudding?
No, I haven't, but I've heard of it.
Do you know what that is? Oh my God, it's exactly. Incredible. Yeah, if there's anyone that's listening to this and hasn't gone to, I think it's the Pudding. I'm going to find the URL so I don't send them to some weird stuff. It's pudding.cool.
Pudding.cool.
And yeah, great URL. And it's like, oh, just incredible. It's really nice. Their visualization is like I think the best I've ever seen on almost any website.
Oh, okay. Yeah, I mean, I gotta check this out. I think I need to see more like general data science focused journalism, at least, given that I think my feed of news has been pretty, I don't know, it's hard to explain, but I think it's just straight up, it's continuously lame. I don't know if there's a better way to put that.
Yeah, have you seen, I think it's Kevin Systrom's RT.live site?
No, what's that?
Oh, so Kevin Systrom's the founder of Instagram, and he, I guess he's a data scientist now. I don't even know he's but he put out the, like, no holds barred, the nicest Jupyter notebook and most well documented Jupyter notebook I have ever seen. Like, this thing is gorgeous. It's super nice. It's really great, and it's based on this principle. It's a coronavirus related one, that the only metric that we should, if we had to care about like one coronavirus related metric, we should care about RT, which is the number of people that you transmit the virus to if you have the infection. Yep. And so if it's like if it's above 1, then it's bad. If it's below 1, then it's good. And if it's 1, it's like gonna stay flat. Yep. And that's it. And so he like implements this Bayesian-based method that gives us confidence intervals around what RT is on a state level, and then just like does it in a nice interactive way on the website. And then he has a Jupyter notebook that explains all the methods, and it's really nice. And no one was expecting it. I had no idea that he was working on data science stuff since he left Instagram, but apparently he turned into like a god tier data scientist in, you know, a year.
I think that is kind of like the goal. Once, like, if I were to become just financially like independent at that level, or not even at that level, like let's say 1/100th of his level, I think my job every single day would just be doing data science projects like that. But also it brings into question like the large amount of like COVID data science projects that I've seen like recently just on the web. And it's interesting because I've been on Reddit and like looked at these successions, and people are just like, I've seen one side which everyone's like, what was initially happening, trying to like, you know, do as much as they could. And then in terms of analyzing this data or like doing something with it and like talking about it. And then recently, I think there's been more of like a backlash towards the fact like please stop like giving us projections or like what you think like the data, like the COVID-19 like modeling numbers are going to be for the future, because it's like it's only hurting and like displaying like fake information on like we don't like, who knows if your model is going to be correct, I think was like the biggest question there, right? And like if everyone creates these models, then like at some point, you know, like the news articles, if they haven't already, have just like picked this up and just kind of like put like COVID-19 is going to kill 2 million by end of 2020, right, or something like that. New models shows like half of all Americans have, or something, you know. Have you seen any of that like recently in terms of your work or just generally on the internet?
I've seen so much of it. I've seen like a ton of COVID-related data science posts like everywhere. Like everyone is getting access to the same Johns Hopkins data, is like, you know, getting that same R package. It's like the R package COVID-19 or something. And it's like tossing their histogram on it, throwing it into a shiny dashboard, and it's like, boom, I've saved the world. And the thing is, like, I believe that all that stuff, especially the visualization stuff, is incredibly useful. Like especially very early on in the crisis, like I have a lot of family in Florida, and they were kind of asking me like, oh, well, we had this number of cases per day, and I can't find a way to like look at like, is that more than it was last week, or is it like less than last week, or like where is this kind of trending? And especially when this started, there was really not a lot of ways to really visualize the data on a county level over time. And I looked for a bunch of places. I was like, there's no way someone hasn't built something like this. And I eventually found like a really good dashboard that was just built by someone that knows Shiny and R well. And they just visualize the data. They're like, this is where it's going. They're not projecting anything, but they're just visualizing the data that they already have. And that was incredibly helpful for my family. And I sent a link to them and they used it. But actually before I found that dashboard, I was making my own little graphs for them. Like my brother lives in Leon County in Tallahassee, Florida. He goes to school over there. And so he was like, hey, Tyler, like how many cases were in Leon County like last week versus this week? And so I just like used that R package, downloaded it, like made a little graph and sent it to him. And I think in terms of visualization and interpretation of like results that have already happened, I think the data science community has done a very good job about being the first to really spread information and spread good information about this crisis, and in the face of like just a lot of bad information on the web. I think in terms of modeling, if you have never done a disease model before, and you've basically done like the Titanic data set modeling with like a random forest, then it's probably not going to be in your best interest to put out a COVID related model. Like that's probably a bad call to do that. But I think if I had to kind of rate the data science community so far, I would say in terms of COVID, it's done a lot more good than harm. Especially when you see like, goodness sakes, like a lot of the actual news sites were putting so much bad stuff out there, like from even into like early March. So I would,
a lot of it is, I think, like stuff that's mostly like taken out of context, right? Like I know one of them like was related to surfing, was like someone was saying like I would never, like the ocean is the last place I'd ever be right now because of like COVID, and then everyone stopped going out, which is, I guess, like probably good too, but at the same time, like she later explained like it was because of the fact that at that time, like the specific like there were so many people on the beaches, and they hadn't shut down those beaches yet, and so to like make it more of an association between like there's germs in the water that you can like get through your eyes versus there's just a lot of people out on the beach, I think is something that is like kind of the first culprit that kind of needs to get obviously like shut down. But yeah, I guess on the second thing also is like back to like talking about the how visualization helps and how you helped your family. I mean, I think that's like super practical, super like that's great. And I haven't even seen some stuff that I feel like myself would be just like useful, right? Like if I think the other day I was trying to look up like hospitalization rate of COVID versus like the flu. Like how many people that get COVID or the flu get hospitalized, right? And I couldn't find that, like just the percentage, like how many, like what's the chance that I'm going to go to the hospital if I get this? Like that's all I want to know, okay? For like my age group. And they show you like the number of people that have been hospitalized out of like 100,000. And then I'm just like, but that means nothing to me, right? It's like I have no idea like what that number is compared to like another disease that I might have gone before. And maybe that's because of the case that like I don't know, that might not even help me anyway, because of the fact that I don't know anything about what chance I would regularly get the flu. Is just because of the fact that I've had it before, that I can kind of like feel it. But just like the idea of severity and like the idea of having that like just a little bit more numbers around the fact that because I think initially it was always like, oh yeah, you get it, you're young, you'll be fine. And then now it's more like, oh, you get it, but if you're young, you can still die. And then like there has to be some sort of like more data around that, where they're just giving you some more bounds towards like what's really going to happen to you, you know, like, and like I think that is where it's more helpful in terms of then giving yourself more guidelines on like what you should and should not be doing, you know, like you know, I think that's just like generally helpful for me. I don't know about what you think about that.
Yeah, I mean, I just wish that every time someone reported a number, they'd also report the confidence intervals around it, you know?
Yeah. I think.
No, I mean, I think kind of back to what we were saying earlier, I'm appreciative that the data science community always takes a critical look on itself and a kind of self-roasting mechanism.
Yeah.
I think that's a very positive thing that, I mean, it just makes the community better and better. Yeah, that's one of the problems with the health system in the United States is it's really hard to get really good data about it, and everyone's kind of figuring that out all at the same time. And I'm sure like all the people that work in medical startups and like biotech and stuff, they're like, yeah, you know, everyone's figuring this out, but we've known it for years. It's really hard to get good data about the stuff that happens inside hospitals in the US.
Yeah, I can see that. And it feels like it's like the healthcare general system has I've heard a lot of crazy stuff about how that like speaking of bad data sets before, like I think we were talking about the electoral system, you know, obviously you feel like maybe just prior disposition to that might being a little bit messy and subpar just because it's like, oh, government work, go, everyone, you know, in that kind of scheme. But also I think within healthcare, that's where you get a lot of the different kinds of privacy laws that then occur that kind of like shields up a lot of the data there. And then it becomes a fact of like where it's like GDPR didn't even apply here, right? Like GDPR always existed within like health with HIPAA, but even more so. And so that's where we're seeing a lot of the kind of like, this isn't going to be something that, you know, one person is just going to solve, right? Like if this was like someone like hacked a system and now like here's like a data dump of all their logs, like someone in like some far, you know, country or like somewhere in the US would probably be able to like parse through and figure it out. But here it's, I think, more so definitely an organizational effort than just some lone star person.
Yeah. Yeah, I guess one of the things that I just don't know much about the U.S. healthcare system. Like I've realized that more and more. My book club that I'm in read The Price We Pay, which is basically about the cost of the U.S. healthcare system, and I would strongly recommend the book. I think it was really great. But even after reading it, I'm like, wow, the more you think you know about the U.S. healthcare system, the less you like actually know. I think back to what we were talking about earlier. I feel like there's a not necessarily natural, but a kind of a natural inclination of data scientists whenever they see a problem that kind of has some data in it to help in some way to like, oh, can I visualize this in a way that someone hasn't visualized before, or kind of trying to push the bounds of what the data can actually tell you. And then the flip side to that is data scientists tend to butt into other professions that also do data science work, you know, so you have all these epidemiologists that have been studying this their entire lives that are like, wait, like, don't do this. Like, we know how to do this. I've spent my entire life working on this. Like, please stop making your histograms. Like, I can do this.
Yeah, I agree.
And it's, I don't know which side I really like fall on. I think both of them are kind of right. Like, it's a good idea for data scientists to want to help other groups. And visualize data and work with data when they can or when we can. But it's also a good idea to rely on experts who have spent their whole life working on either healthcare data or disease modeling data.
Yeah,
I can think both things at the same time.
Yeah, I would agree with you there. Like, and I think the good example is like, like the project that you did with like the Hillary slogan. So I'll paraphrase this really quickly, but you found a bunch of, or no, it was leaked, right? A bunch of like Hillary slogans that were not used, but they wanted to. And in like about, I'd say like 10 to 15 lines of code, you could just basically use like one of the recurrent neural network packages to like create these new paraphrases of slogans, right? And I think that's like something that really resonates with me, just because like I want to be that person that can just take like a package and then reapply it and think of like the strategies in which you can do so, right? And I think in terms of a lot of the stuff with the epidemiology, it's like, no, you have to be the one who's like building that like recurrent neural network, so to speak, like that underlying layer of it. And like you can't just apply, some like
scikit-learn
scikit-learn package on top of it and then visualize it. Like there is like a need for that, like don't get me wrong, and like I think there's a lot of people that undervalue that asset because there's so many different industries where you can apply that and do very well in, because you're thinking very strategically. But at the same time, this one, which is like a huge problem, is probably not like the one where it's the one where like people are applying their model forecasts in the same tune of which we're like having fun with the Hillary slogans.
Yeah. Well, that project was kind of interesting because so what happened was anytime that a campaign is kind of starting, they are trying to figure out what their actual slogan is going to be. And so there's usually this meeting where everyone tosses every idea that they have on a wall, and then they write them down. And then eventually they figure out which ones are better or which ones are worse, and then they choose on one. And so that the list of all of the random ideas that they had, it was like hundreds and hundreds of random ideas, and they were leaked. And so as soon as I saw that, I also, I was like, oh, I want to do something with this eventually. And I think this is really interesting. And so then someone built a text generating recurrent neural net package that made it incredibly easy to just toss in a bunch of training data and spit it out. And of course, anyone that has worked with recurrent neural nets knows that like a few hundred slogans does not create a good data set for recurrent neural networks. It does not work well, for sure. And so don't come out of this thinking, oh, if I have a data set of a couple hundred, then neural nets, here I come. That's not gonna it's not gonna work well. But it doesn't matter, and I just thought it would be fun, and so I tossed them all on like a regular RNN, and then I thought it was funny the results that came out of it. And probably 50% of the data science projects that I've worked on are as stupid or stupider than that. That's like about in the middle. I think that my favorite dumb data science project that I did was I play a bunch of ping pong, and I played a bunch of ping pong for quite a while, and I had a few friends that also loved to play, and we would play before stats class on like Tuesday and Thursday morning. And so we would like get there like really early, like between like 7:30 and 8, and we would play for like an hour and a half or something. And it was just basically 3 or 4 of us that played the entire time. And I decided I wanted to record all of the games over the course of like a year. So we had like hundreds of games over the course of a year. And we had games between each of the 3 of us. And I would always beat my friend Kent, and Kent would always beat my friend Juan, and Juan would always beat me. And so we obviously had the question, like, who is the best? Like, who's the best one of us? Like, it's always happening this way. And so we had like score differentials. And so there's this man many years ago named Arpad Elo, who's a chess player. And he invented this method to give people basically an Elo score based on their kind of predicted point differential in chess, their kind of predicted win versus their actual win. And so you had a certain score, like you have like 100 Elo points. And then what happens is you take like 20% of them and you put it in a pot, and then whoever wins gets the entire like set of points. That's kind of fundamentally how the algorithm works.
Yep.
And so I just applied that Elo algorithm to our ping pong games. And
it
then
works, right?
it works great. Yeah, it's
Yeah.
great. But it's like, if RPad, and there was a really nice Elo package in R, because there's a package in R for everything you want to do in life, I guess. Um, yeah, and so it's like it's really fun to do those types of kind of little projects that someone somewhere is going to be interested in. They're mostly for you to get to learn some new method or to figure something out or to get some interesting result that you think is kind of funny. Or you have other ones that you think are like actually important. But I tend to only have one of those two projects. Either it's going to be really dumb and I think it's going to be really fun, or I think it's like crucial and important, but there's not a lot of like in between.
Yeah. Do you think either of those have helped in terms of like even though they're fun for you, right, and like intrinsically they're really great, do you think it's helped in terms of like just building your career in different ways, in terms of landing jobs, in terms of like maybe just you learning about it and then like spearheading towards getting a job, or like even like getting enough like media attention, or not media attention, but just general like attention for having a portfolio that kind of helps with building your resume.
Yeah. Oh, for sure. I'd say that like having some sort of a portfolio where you have some work that exists online
Yeah.
that other people can Google your name and see is like a remarkably underrated thing. If you're a data scientist and I Google you and the only thing that I can find is your LinkedIn page that says scikit-learn, that doesn't really help me in terms of do I want to hire you or not,
Yeah.
because there are a million people on LinkedIn that say they know scikit-learn. So what am I supposed to do with that? And then I basically have to fall back on, oh, you went to Stanford? Okay, I'll hire you. And especially coming from the University of Florida, which is not Stanford, you want to have some other metric that they're going off of than like prestige of the average graduate that comes out of the college.
Yeah, I agree. I agree on that totally. And I think that like Googling someone is like the first thing that you probably do after your resume just piques interest, right? And for me though, I think geared towards more of like a preference towards people that have that like intrinsic side and interest of data science as well.
Mm-hmm.
And you can show that with projects specifically.
Oh, yeah, for sure. It's the easiest way to tell if someone is really interested in data science or they read in Forbes that it was the sexiest career title of like 2010. And then they're like, all right, I want to do that.
Yeah,
It's the
exactly.
easiest way
Of
to do it.
2010, yeah. It's 2020
Yeah.
now,
Yeah. Well,
Mars just come out with a new article, I guess.
yeah. Yeah. What's it going to be? Data engineer, software engineer, BC? I don't know.
Yeah, I think the sexy job that Forbes would put would probably be like, AI researcher, deep learning researcher, but like actual like job needed data engineer. Like,
Yeah. Yeah. Yeah.
given
Oh my
just
God.
how
Mm-hmm.
important that is. Um,
Mm-hmm.
but Tyler, this is a great talk. I love talking to you about all this stuff, and I'm sure we will in the future as well. Is there anything that you wanted to bring up that I didn't get to, or just something that you'd like to point our listeners in your direction?
You're basically asking, do I want to toss my Twitter handle and
Yeah,
URL up here?
we can do
Yeah,
that
I mean,
anyway, off podcasts. On the metadata for sure.
mhm.
Uh,
Let's see. Um, I guess we've talked about most of the stuff that I think is kind of interesting. I talked about Bochild, we talked about Misinfo, we talked about Facebook. Boom. Yeah. So I guess the easiest way to reach me if anyone wants to tweet at me, it's Tyler J. Richards. And then there's tylerjrichards.com. And like I respond really fast because I'm always online. I think that's pretty much it. Thanks so much for having me. Like I've really enjoyed it. I think interviewer query is like a great idea. I think one of the most influential and impactful things you can do is to bring people up the economic ladder, whether that is through something like interview query, which hopefully gets people from wanting a data science job to making a data science salary, which is an extremely admirable thing to get people towards. Or if you're like in education or something, that brings people up the economic ladder that way. I think it's a seriously underrated way to help people, is to help them make more money, and then they can buy things that they like.
No, definitely.
I think it's great.
I'm gonna save that like last 20 seconds of you talking and write it down, because I've never heard a better way to put our mission statement. Literally, I think you did it better than I have thought about it in like 10 months.
Cool.
But yeah, thanks, Tyler. And I'll talk to you soon.
All right, talk to you later.